Today's topic is centroid, or it has so many names. It has a name center of gravity, it has also a name center of mass, and also it is called center of inertia. Okay, and in short it can be written CG. Okay, this is center of gravity or centroid. These all are the same term. And here we discuss first what is center of gravity or centroid. We first discuss the definition of centroid of a discrete body. Okay. Now, what is discrete body? A discrete body is formed with finite number of mass particle. Okay, let it be a discrete body, so it has a finite number of mass particle or particle of mass. Let it be the first particle is of mass m1, the second particle is of mass m2, and the third particle is of mass m3, and fourth particle is of mass m4, and so on. The nth particle is of mass mn. Right? This is the discrete body. It has n mass particle, and the position of n mass particle are p1, p2, p3, p4, and so on, pn. Now we have to find, or we want to found the position of center of gravity. Okay. Now to define the position of center of gravity, we must require a frame of reference. Okay. We want to find the center of gravity from the line. This line can be named as LLS. Okay, that is, if G, this is G, be the center of gravity. Usually G is denoted by the center of gravity. G be the center of gravity, then we have to find or this distance, right? This is Gm. We have to find Gm. This is the center of gravity of the mass particle or of the discrete body about the line LLS. Now to found the distance mg, we first found the distance of all the particle. Let it be r1, that is the distance of m1 from the line is r1, and let the distance of m2 from the line, this is r2, distance of this is r3, and this is r4, and the nth particle is rn. Okay, we first find out all the distance or the distance of all the mass particle. Now we found a sum, which is the product of mass into respective distance and mass into respective distance and mass into respective distance. Okay, like we find the moment of force of a about any line, right? If we consider this is force and this is distance, so this is like moment of force, and we write this by summation as I, this is equal to 1 to n mi ri. This is the sum of the product of mass into distance, and G be the center of gravity. Then by the definition of center of gravity, or it must be expressed the center of gravity if we know the total sum or total of the mass, that is total of the mass is m and this is equal to summation mi. Okay. Now we multiply the total mass with the distance mg. Okay. Let it be n because this m and this m coincide. So we find the product of mass into the distance mg. Let it be capital R. So we get m into capital R and this is R into summation mi. Okay. Now since G is the center of gravity, then we must write R into summation mi. This is equal to summation I. This is equal to 1 to n mi into R. Okay. So we get the distance R and this is given by mi Ri by summation m. Sorry, this is mi. And this can be written as summation mi Ri by capital M. This is the total mass of the body. If we consider the body is discrete. Right? Now if the body is not discrete, okay, let this is be a continuous body. Then we divide the body into small pieces of elementary mass. Let it be or let an elementary mass be dm. Okay. Now when the body is continuous, then the summation is not allowed. So if the distance of this elementary mass is r and the distance of center of gravity is capital R, then this result can be written as this is capital R and this is integration r dm by integration dm, and integration dm, this is capital M and this is over whole mass. Okay. And obviously integration is taken over the whole body, and this is the definition of center of gravity of the continuous body. Right? Now we have to find the center of gravity of this body about two axes, that is about x axis and y axis, that is in two dimensions. Now if this is the position of CG, and usually the position of CG can be denoted by x bar, y bar. Okay. Now this distance is x bar and this distance is y bar. We have to find x bar and y bar different formula. Okay. Now we also take here an elementary mass dm, or it can be taken as d rho, where rho is the density of the material. Okay. Now the position of the elementary mass is also xy, because at any point P can be taken as x, y in two dimensions. Then from the definition of center of gravity, if we take the moment about y axis, then we get the formula as x bar into integration dm. This is equal to integration x into dm. Right? So x bar, this is equal to integration x dm by integration dm. Similarly, if we take moment about x axis, then we find the value of y bar like this. This is y dm by integration dm. and this dm, this is the total mass. If the total mass of the body is capital M, we write here capital M, here also capital M. Similarly, if we have to require the center of mass in 3-dimensional coordinate system, then we can write another result z bar. This is equal to integration z dm by integration dm. Okay, these are the definition, or we say these are the formula to find center of gravity of a body. If it is discrete body, or if it is continuous body in 2 dimension, or it is in 3 dimension. Now we deduct the center of gravity or the coordinate of center of gravity of different type of bodies in upcoming classes of this playlist. Okay, thank you for watching.